All right, so we are starting, well, just to clarify, the lesson for today, we're trying to do zero product property. You're going to try to learn how to do this zero product property. But if you've been following along with the top 20, you're already good at it. All right, I want you to think for a second. There's three forms of an equation. There's vertex form, there's general form, and there is factored form. Which one is this best written from? What do you think? Vertex form. I agree with you 100% because we have the vertex really clear. It's 2, 3. Now, would everybody write me the equation for this? And be careful. Look at it closely. Don't fall into the common trap. I'll pause for a second while you write this equation. First of all, you have to have y equals to be an equation. Second of all, you got to know that vertex form generally kind of looks like this. And then you got something in here and you got something out there. See if you can finish the deal. But I betcha, so you know, about half of you are going to make a little mistake. There's 2 places where you could make those little mistakes. I'll pause while you give this a shot. All right. So did you say x? And we know this is 2, 3, right? The common mistake is to go like this, but there's another mistake to make. Okay, we all know that you're not supposed to do that, right? It's supposed to be negative 2, 3. But did you notice the other thing that's going on? Who noticed it? Yes? It's been stretched. So this should normally go over 1 and down 1, and it didn't. It went over 1 and down 2. How many of you noticed I have to put a 2 on the outside? Raise your hand if you did. Okay, that's only a few of you. I warned you that a lot of people would miss that. Can you set that there? Thank you. So if there's a 2 right there, now you got it almost all the way right. It would still be wrong. You got it? You need a negative. Why do we need a negative in the equation? Because the thing's upside down. So I bet a lot of you missed out on both of those 2 things. You needed a negative in the front to show that it's a flip. Okay? It's got to be careful on those. That's a really common mistake. All right, so now that's vertex form. Do you remember how to get general form? Generally, you just multiply it out. Multiply it out. So don't forget the order you have to do it in. This would have to be done first. Remember, it's not x squared and 4. You have to do the whole thing. Write it all the way out. X minus 2, do first, outside, inside, last. Then go through and multiply everything by this, because that multiply comes next, and add is last. Go ahead and multiply that thing all the way out and get me general form. I will pause for a second while you try that. Okay, so the first part is this part right here, and I'm going to leave the negative 2 alone, and I'm going to leave the plus 3 alone. They're going to stay the same. All I'm doing is this part, x squared minus 2 and minus 2 makes minus 4x, and the last makes plus 4. Then I distribute this puppy out. There, there, and there. Negative 2x squared plus 8x minus 8 plus 3. Then negative 2x squared minus 8x, or sorry, plus 8x just stays the same. That and that go together, minus 5. Slap a y equals on the front of it. Raise your hand if you got the same thing that I did. Okay, good. Now, if you got a mistake in there, look it over carefully and try to figure out where you messed up. Usually it has to do with negatives, and a lot of times it's in the distributing process that people mess this thing up. All right. So, that's a good challenge kind of question. Here's the lesson for today. First, yes, question? Okay, so back to A and B are real numbers, then find how many solutions you can have to this. Well, do you get if you have 2 things multiplied equaling 0? That they're only going to be 0 if what? If one of them is 0. So either A is 0 or B is 0. Could they both be 0? Yeah, that's legal. But either one or the other or both. Okay? So That is the zero product property. It's a product, because a product means you multiply two things, right? Of two things have to equal 0. And do you remember that the setup we have is usually like this? X plus 4 and x minus 3 equals 0, for example. And we just say either this has to be 0, which would be x equals negative 4, or this has to be 0, which would be x equals 3. Those two answers are our solutions. That's the zero product property. You've already done this. This is something you learned actually 2 years ago, and I refreshed your memory with the top 20, so it should be fresh and easy. All right, let's do one more like that. Let's say it was a little more complicated once it got factored. That would be a nasty one to factor, but let's say it came out to this. I got 2x plus 3 and 3x minus 1, both of them equaling 0. We just have two little mini equations to solve. Figure out what the two answers must be. One answer for this and one answer for that. Yes, your answers are fractions. I'll pause for a second while I give that a shot and check with the kid next to you. See if you get the same two fractions. Don't try to do it all in your head. Otherwise, you get things upside down a lot of times, or you forget a negatives a lot of the times. So write out the work. Okay, you should have said 2x plus 3 equals 0 and then solved it. And you should have said 3x minus 1 has to equal 0 and solved it. And they're just two little mini equations. These are just algebra. Super simple. Minus 3, final answer 2x equals negative 3, so x must be negative 3 halves. And on the other side, 3x equals 1, x equals 1/3. 1/3 and negative 3 halves. Raise your hand if you had those two answers. Okay, good. So that is the zero product property that you've known since algebra, and it basically is the way you solve quadratics. What if we were starting this question and the thing wouldn't factor? I can't get it to be factored like this. If you can't factor, there's a two-word answer. No, that's not no solution. It's a good question. You can get a solution, but there's some fancier way. Starts with a Q and the last word ends with an F. Or starts with a Q and starts with an F. Yes? The quadratic formula. If you can't factor it, the quadratic formula can get you these two answers, but without the factoring. So let's say we started with one like this, and that is not going to factor. I can't get that to factor. Then you can always use the quadratic formula and solve it. But I'm not going to ask you to do that right now. There's a whole other day for the quadratic formula. But you know how when they get done, they look kind of like this? That kind of stuff? That's the quadratic formula kind of answers. There's still two answers because it's plus that and minus that. Plus that and minus that. But anyway, we'll do the quadratic formula a different day. I just want to remind you that we're factoring, and we made them factor right nicely today. Okay, almost everything's going to factor nice. But I just want to remind you, what if it doesn't factor nice? Two words? What are they? Quadratic formula. Good. All right. So when the product of two or more numbers equals 0, at least one of them must be 0. So if I move on to these and solve it, remember me saying if you can factor it, you should. This is factored. 15 times x. Do you get that that's factored? This is a factor and that's a factor. 15 can't be 0, but the other one could be. So what's the answer got to be? X equals 0. Good. This one could equal 0. That one could equal 0. You could set up two little equations. We did one just like that 2 seconds ago. This one, I could get an answer for this and an answer for that and an answer for that. 3 answers. That's not a quadratic anymore. That's an x to the third. Does anybody know the name for it when it goes beyond quadratic? I think you're right. It starts with a C. Cubic. All right. This one, super simple. What are the answers? Boom, boom. Negative 6 and positive 3. All right. For this one, that would be a fraction. That's a simple one. 7. What's that one's answer? 0. Because what it's saying is this is like its own little separate parenthesis, and it could equal 0, just like 4x plus 5 could equal 0, and just like x minus 7 can equal 0. This x can equal 0. That's one of the answers. This you have to solve a little bit, and you come up with x equals negative 5/4. And this last one is x equals 7. 3 answers is not uncommon. All right. Please look at these last two, because we always try to hammer home the common mistakes. A lot of people think, okay, so I should just set these both equal to 0. Set that equal to 0 and set that equal to 0. Why can't you do that? Because it doesn't equal 0, it equals 5. And no, you can't say 3x plus 2 equals 5. That does not work. That only is true about zeros. That if you have this one and this one multiplied, one of them has to be 0 to equal 0. If it's set up this other way, it just doesn't work. If you subtract 5 from both sides, then you'll have something like this. And is that factored? No, it only works if it's factored. So that's why that one's messed up, is somebody thought you could just go, well, I'm just subtracting 5 from both sides. Even though that should be a minus 5. But anyway, either way, that does not work. The only way you could do it is if you actually multiply this thing all the way out and then put the minus 5 in with it, and maybe it'll factor then. Would you please go ahead and multiply that thing out, first outside, inside, last, then put the negative 5, I'm changing it to a negative, and put the negative 5 with the other number, and then maybe what you have will factor. But don't think that it's factored just because you have 2 parentheses. If you have 2 parentheses and a number after it, it's not factored. Help me FOIL it out. Firsts. And the outsides? And the insides? Yep, and the lasts? And then I got to put a minus 5 by it, and then I got to put those together. What do those two together make? Excellent. Now, has anybody found a way to factor this puppy yet? Well, I got to put these together first, maybe. So I'll go x squared minus 2x minus 8 equals 0. Could that still factor, maybe? Maybe it can. So what multiplies to negative 8 that might add to negative 2? Yes. Negative 4 and positive 2. So I'm going to it will factor. So I can do it, but I just had to do a whole bunch of work first. X and minus 4 and plus 2, and then sweet. Now it factored. And I can get my 2 answers now. X minus 4 equals 0, and x plus 2 equals 0. So x equals 4, x equals negative 2. Do you get that this was not in factored form? So first I multiplied it out, and I got what form? What's it called? General form. Then, once it's in general form, you can factor it. Yay, once it's factored, you can use the ZPP, zero product property, and get your 2 answers. What are those? There's 4 names for them. The roots. Give you another one. The x-intercepts. No, that's not the vertex. The roots, the x-intercepts, the zeros. You ever heard of the zeros? And the solution. These are so important, these things that we're finding, that they have 4 names. The roots, the x-intercepts, the zeros, and the solutions. So it'd be a really cruel thing, and I think we should do it sometime on a test, to ask the kid, okay, here's the problem, now tell me what the roots are. Now tell me what the zeros are. Now tell me what the x-intercepts of this are. And now tell me what the solution is. And if the kids knew what they were doing, it'd be like, it's the same thing. Boom, 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 boom. All right. So the zeros, look at that, it called it zeros. But do you get that they are the x-intercepts? See? Zeros and x-intercepts, they're also called the solutions. And the roots. They have lots of names. As you go up and higher in math, a lot of times they call them roots. All right. The fact that there's zeros makes more sense, though, because if you think about it, when you take this number and you put it into the equation will equal 0 when you put in those x values. The y comes out to 0. See? The x-intercepts have the y equal to 0. All makes sense when you start knowing all these pieces and that they go together. Okay, we're getting close here. I want to go to this yellow one here. This one, find the zeros of this function and then verify that they are zeros. Well, I can see them. They just jump right out at me. Are they jumping out at you? All right. Take a look up here. Some of you guys are getting a little sleepy after lunch. Stay with me. Okay, that's and that are the x-intercepts, the zeros, 1 and 5. How do I prove that they're actually zeros? Yes. Yes, but I mean on this, if 1 is really a 0, what can I do? Plug in a 1. Everybody, stick in a 1 and do the math on it and figure out, does it really come out to 0? Did that work or not? All right. So 1 minus 6 made negative 5. And negative 5 plus 5 made 0. Yep, it works. And then if I try 5, trust me, stick in a 5, it would work. All right. Ends up being 25 minus 30, which makes negative 5. Then you add the 5 and you get 0. Okay, good. So find the zeros of this. Hint, if you graph it, you'd be able to know where it touched the x-intercepts, and the x-intercepts are the same thing as the zeros, right? Could you have made any more noise with that bottle? All right, so please find the vertex and graph this puppy right now. Put that away. Wasn't it? All right, so yeah, you can skip all the even prime numbers, but there's only one even prime, so. All right, fine. What if I said you could skip all the odd prime numbers? Yes. Well, that'd be a lot of them to skip. Every other. All right. So every other odd prime. Oh my God. So what are you going to be skipping? What's the first one you skip? 3, and the next one you skip? 7, and the next one you skip? Etc. In fact, you can skip all the even primes and every other odd prime. All right. I didn't really want to cut this one down very much, if you can't tell. All right, so get to work on that, and I am going to be grading projects for the rest of the hour. Save it.